We just finished a subject of voting theory and voted on what we wanted to look at for the rest of the semester. And so last week we figured out that we wanted to look at game theory and financial math. And so game theory goes really well with what we were doing with the voting methods. And so what we're going to look at is the next chapter in our book, which is fair decision making. And so a lot of times, we're always making decisions. But let's say that you and two of your friends went out and you guys bought a pizza together. What would be the fair way to split up, let's say, a pizza amongst three friends? So how could you divide? A pizza fairly? Among three people. So what do you think would be the fair amount of pizza for you to get if you were there with your two friends?
One or two, maybe?
One or two, like one or two pieces?
Yeah.
Okay. I mean, so it really kind of depends, right, on how we kind of cut the slices. I would feel really slighted if I just got this. And my other two friends, got to share the rest of this. I mean, we could have huge pieces, right? So what portion of the pizza would you want to get? Okay, so I've been seeing in the chat a third of the pizza, right? So you would feel fair if you got a third of this pizza. Would you feel it was fair if you got to eat half of it? Fair for you? Or would you feel your portion was a fair portion? I'm seeing some heads shaking, And so how about they took what they wanted and you were left, they had all they wanted and you were left and you with half of it. Would you feel then that was fair? They got what they wanted, they were happy with what they got, and they left you half of that pizza. I feel it was probably more than fair. I would be probably really happy because that's my favorite food. Unless this all could change, right? What if, you went out to the pizza place and your friend, one of them is a vegetarian and one of them really loves pepperoni pizza and you really don't care between the pepperoni and the vegetarian, you like both of them. And so if you split this up in half and you have half pepperoni over here and half vegetarian over here. So we're coming in now with some preferences and not everything is the same. And so that person that is a vegetarian might not be happy if they got 3/4 of the worth of their pizza was pepperoni. Or that person who loves pepperoni would feel gypped if most of their portion was vegetarian. And so what we're going to be looking at in this chapter is looking at decision making among people and having them all come out of the situation feeling that they got their fair worth, at least their fair worth. And so just kind of like when we were doing the voting methods, we had to look at a lot of different terminology. So we're going to just look at some terminology real quick of fair division games. And so first thing we have are assets. So assets are this goodies. In our example, the asset was the pepperoni and vegetarian pizza, or pizza just in general. So, and those are the things that we're going to be dividing. So we have assets, and those are the goodies, or what's being divided. So there's two types of things. These can be tangible or intangible items. So tangible, that could be how much pizza we get, how much money we get. Intangible would be maybe, well, I was going to say chores. You're splitting up who has to do the chores in your household. That would be kind of an intangible good. Not that assets are not always goodies. Anyways, so, and they have in here water rights, drilling rights, broadcast licenses, and so on. So these would be some intangible assets that you're trying to split up. So just with like the voters, we called them players. So those are the parties with the right or duty to divide the assets among themselves. It can be people, companies, states. Oops, okay.
Oh. Okay.
So any questions on that? Not too bad. So just like with our voters, we sometimes denoted them. P sub 1, this would equal player 1. P sub 2 would equal player 2. Dot, dot, dot. P sub n is equal to player n. Okay, so we have a value system when we're looking at making our choices and dividing things up. So this means by which player gives the value to any part of the asset. It can be a dollar amount or a percent of the whole. So like I was talking about, some person, if we're splitting pepperoni and vegetarian, someone might really like the pepperoni and someone might hate the vegetarian. So if they hated the vegetarian, they're gonna count that piece as 0 weight. So they would give all their weight to that half of that pepperoni in that last example. So our value systems could be different between the different players. A fair division method, this rules that govern the way that the game is played. So when you decide to split something up, you're going to decide which way that you guys are going to split it and how you're going to fairly split it. So we're going to look at different methods in this section on how we can make divisions, so that everybody comes out, every player comes out feeling that they got their fair share at least. Okay, so there's some assumptions that we are going to make that are not always true. But rationality, each of the players is thinking rational. Entity seeking to maximize his or her share of assets. We assume a player's move are based on reason alone, taking emotion, psychology out of the picture. Okay, so the person that is getting some of these assets, the player, their rationale is, I want the most I can get. The most I can get, at least it's going to be fair, my fair share, but if I can maximize what I can get, that's what I want. And so that was where we're taking that emotion or psychology out of it. So that first example, and I said, okay, well, what if you get half of the pizza? Would you feel right with that? Someone was saying no, or shaking their head no. Well, because they wanted everybody else to have their fair share. That was their friends, you know. They had some psychological reason of not thinking that getting half was fair. Cooperation. The players are willing participants and accept the rules of the games as binding. So whatever they get at the end, as long as they got their fair share, they should be good. And then privacy. Players have no useful information on other players' value system and thus what kind of moves they are going to make. Okay, so that sometimes is hard when if you're talking about family, right, or your friends, you know exactly probably what preferences they may have on certain things. And that was where it could come into play where we're doing something voting. Like you guys wanted to go out to dinner and your family's trying to decide what restaurant you're going to. You might know what your siblings like and what they don't like, and you know that, well, none of them are going to vote for my favorite restaurant, so maybe I should change my strategy here and pick something that I really like, and other people might like. I know my family will like too, so that it might work out for your benefit. But in this case, we're assuming we don't know any of that information. So another thing that we need to assume on these fair division game is symmetry. So players have equal rights in sharing the assets. Okay, so this is a main point that we're going to be using when we are looking at, did this person get a fair share? What is that fair share for the person, one of the players? And so players have equal rights of sharing the assets. The consequence of this assumption is that at minimum, each player is entitled to a proportion share of the assets. When there are n players, they each is entitled to at least 1 over n of the assets. So like the first example, there was 3 people sharing the pizza, and so 1/3 of that pizza, if you get 1/3 of that, that's your fair share. And at minimum, your fair share is 1/3. And if you get more than that, then that's fine, but you're entitled to 1/3 of that pizza. Okay. So I already told you how we can denote our players. So given a set of players, piece of 1, piece of 2 through piece of n, and the set of assets. So what are we splitting up? And the ultimate purpose of the fair division game is to produce a fair division of S. But what does this mean? Okay. So the fair share to a player, suppose that S denotes a share of the set of assets, capital S, and the player's P is one of the players in the fair division game with n players. The share is called a proportional fair share, or just a simple fair share to P, if P's opinion of the value of S is at least 1 over n of that value of S. Okay, I'll explain a little more when we get into detail what this is talking about, because this comes into the situation where, you know, with that pizza, when we decided half of it was pepperoni, half of it was vegetarian, that again, that one person who loved pepperoni, hate vegetarian, like they have no weight to that vegetarian. And so their fair share proportion is only going to be towards that pepperoni pizza. And so again, we'll look at that concretely. Okay. So here is an example. So am I going in the right order? No, so that was not. Okay, so here's an example. So here's a fair division. To assign each player a fair share, we start with Henry, because with him, oops, I'm missing something. That's slide 10. 5, 7. I'm looking for slide 7. And I don't see it. So let me just pull an example from the book. Okay, same people. Henry, Tom, and Fred are breaking up their partnership and dividing amongst themselves the partnership real estate assets, equally owned by all three of them. The assets are divided into 3 shares. We're going to call them shares of 1, shares of 2, shares of 3. S of 1, S of 2, S of 3. Okay, so we got 3 players here. So when we're doing these, just like with a voting method, sometimes it was helpful to put down making a table. And so putting in your players, so let's just write our players in this column. We have Henry, we have Tom, and we have Fred. And then with them, we're splitting up 3 separate assets. S of 1, S of 2, and S of 3. The assets divided into 3 shares, like I just said. The values of the shares of each player is expressed as percent of the total value of assets. Okay, so looking at the table, if the 3 different groupings of assets or 3 assets that they're splitting up, Henry, that first group that they split up, he believes that's only 25%. That's only worth 25% of that whole. The second group of assets, that weight for him, he likes that much better. That's worth 40%. And the third is 35%. Okay, so when you're looking at a player and you're looking at them weighting everything, this should add up to 100%. So they're splitting 3 things and into 3 groups, and the weight for each 3 groups should add to 100%, which it does. Tom has different feelings though about this, and so he says, okay, this is 28%, I believe, is what the first group is. 35% is what the second group is worth, and 37%. And then Fred has 33 1/3. 33 1/3. 33 1/3%. Okay, so when we have something and we're splitting it up, somebody has to split up the assets. So in this case, it looks like Fred was the person who split everything up. So he took all the assets and he said, okay, I need to split this up as much as possible. And if I was going to split it up into 3 different piles, and because he's the splitter, he's the one who's going to want to make it as accurate as possible, because he's going to be left with one of these groups. And so he should be happy with whatever he's left with. And so we got somebody who's splitting everything up, and then the other 2 people are going to be the first people that get to choose. So if we look at this, we need to figure out what it is a fair share. So a fair share amount for each person or each player, in this case, is 100%. Assets are worth 100% divided by the 3 players. So this is 33 1/3%. So if that person gets assets that is 33% or higher of what they felt, then they're happy. They should be a happy player. It was a fair game. And so if we look at Henry, notice that he only weighs set 1, the asset set 1, as 25%. So to him, this is not a fair share. So I'm just going to cross it out. Player Henry's would be happy to get a set of assets of 2 or 3. So same idea, we're going to go through now with Tom and we're going to look at it and see what he would assume would be fair if he got it. Well, he also does not like S1. So 35% and 37% of the other two, those are greater than 33 1/3. So he would be happy with either one of those. So the question says, which of the shares are fair shares for Henry? So if we call him player 1, his fair share, we would be happy with S of 2 or S of 3. Player 2, if we're looking at Tom, player 2, his fair share, again, he would like S of 2 or S of 3. Which of the fair shares to Fred? Fred, well, he weighs them all the same. I was just assuming that he split everything up, but maybe he didn't. Of the fair divisions found, which one is the best? Oh wait, find all possible fair shares of the assets using S1, S2, and S3 as shares. So our next thing that we want to do is we want to find all the possible fair divisions. Okay, so right away, we know that player 1 and player 2 don't like the asset of set 1. And so they can't get that, they're not happy. So player 3 always is gonna have to get S of 3. Well, there's just 2 different possibilities though. So player 1, let's give them S of 2 then. If they got S of 2, that would mean that player 2 would have to get the remaining one, right? And so the remaining would be S of 3. Not S of 3. S of 3. Player 3, I'm sorry, should have gotten asset of 1. They're always going to get S of 1. So this here, this is one set that is a fair share. Another option, so player 3 again, they have to get share 1. But this time, let's give player 1 share 3. And if player 1 gets share 3, that means that player 2 then gets share 2. There's no other way that we could split this up and everybody feel like they got a fair share. So looking at this, of the fair share divisions found, which we only found 2, which one is the best? Is there anyone that looks like it would be the best for all those players? Our first choice or our second choice? Yeah, so I'm saying the first choice is what you guys are saying, which I agree with you, right? Because if we go back up to Henry, and if we look at the 2 choices, S of 2 or S of 3, he favors S of 2 more. And fortunately, player 2 also, he favors, out of the 2 that he likes, S of 3 more, and so they're both happier. I mean, they would have been happy if it was swapped, but they're happier this way. So not too bad, right? Let me jump to a different one. Okay, so we got 4 people now that we're splitting up this cake. So we got Carlos, we have Sonia, I'm gonna give myself some more space. I'm gonna just start a table while we do this. Maybe I won't. Okay, sorry, let me just go on. Sonia, Tanner, and Whit. The cake has previously been divided into 4 slices. Okay, so the assets are the cake slices, and we have S of 1, we have S of 2, S of 3, and S of 4. This table shows the value of the slices in the eyes of each player. Okay, so basically, Carlos was going to pay money to eat that first slice of cake. He would pay $3. He thinks that slice is worth $3 in his eyes. That slice 2 for Carlos is worth $5 in his eyes. So he must like that better. The third slice is also worth $5 in his eyes. And the fourth slice, that's worth $3 in their eyes. So Sonia, her preference, she would pay $4.50 for slice 1, $3.50 for slice 2, $4.50 for slice 3, and $5.50, excuse me, for slice 4. Tanner, we got $4.25, $4.50, $3.50, and last piece is only worth $3.75 for him. So when $5.50 for the first slice, $4 for the second, $4.50 for the third slice, and $6, well, for the fourth. Okay. So looking at this, which are the fair slices for Carlos, what slices are fair shares for Sonia, etc. And then we're going to go through the line and then find all the possible fair divisions of the cake, S1, S2, S3, and S4. Okay, so if you sum this up, each row, let's figure out what the cake is worth, the total cost. So if we look at summing, he'd pay $3 for the first, $5 for the second, that's $8 so far, plus another $5, that's $13, and 13 plus 6. So the total cost of that cake for him is $16. So let's also look at, while we're doing this, their fair share amount. Fair share. Cost. Oops, I didn't leave myself room. So 4 players, we're going to take that 16 and we're going to divide it by 4. And so that would be 4. We might as well just work with Carlos right now. So Carlos, his fair share, it's $4. And so anything that is $4 or above, he would be happy with. So right now, he would be happy with S sub 2, and he would be happy with S sub 3. So Sonia, we're going to do the same thing. Let's figure out how much this cake is worth for her. Well, $4.50 plus $3.50. Well, that's 50 cents gets me up to $5 plus 3 is $8. 8 plus $4.50 is $12.50. $12.50 plus $5.50. Well, that 50 cents gets me up to $13 plus 5. So that's $18 altogether. And so $18 divided by the 4 people, they believe their fair share would be $4.50 worth. And so they think $4.50 and $5.50. Oops. Actually, this would be work. This one would work. S sub 1 would work, right? Because that's $4.50. S sub 2 would not work. So she's happy with 3 different types. She's happy with S sub 1. She's happy with S sub 3. And she's happy with, I'm seeing if this, I don't know if this will help ordering it a little bit like this. That's why I'm leaving spaces, S sub 4. So Tanner, if we added up all the slices, we got 425. Well, I want to add things that I know that I can add up to $1. So 25 cents plus 75 cents is $1. Plus that $4 is 5. Plus that 3 is 8. So far I have $8. And then this $4.50 plus $3.50, that's $8. 8 plus 8, that's $16 altogether. So for him, if he gets anything that is $4 or above, he should be happy. So Tanner, well, Tanner, sorry, did I say $4.50? But it should be anything of $4 and above. There's only one thing Tanner really likes that is above, oops, I guess there's 2. So he wants either S sub 1 or S sub 2. And then when? So $5.50 plus $4.50, that's $10. $10 plus $4, that's $14 plus $6. He thinks the cake altogether is worth $20. So $20 divided by 4, his fair share is $5 or more. So $5 or more, they're happy with slice 1. And they're happy with slice 2. I don't know why I said that, but they're happy with slice 1 and slice 4. Okay, so find all the possible fair division of cakes with S1, S2, S3, S4 as shares. This is where it might be helpful. Let's see. I'm going to copy this so that we can go through and we can, let's see if I can copy it. Use this table over and over again. Okay, so let's go through and let's start with Carlos. Let me just pause for 1 second. Trying to figure out what was the best way to organize this and keep track. But let's say player 1. Again, let's call them, although they all have different names or start with a different letter, it doesn't matter. Let's just keep player 1. So player 1, let's give him, he's only happy with slice 2 of the cake or slice 3. So we're going to give him S of 2. If we give him S of 2, that means S of 2 is gone. Doesn't really matter there, but it's gone for these 3 players. And so looking at Sonia, player 2 in this case, they're going to get, and we just need to decide, they're happy with the slice 1, and they're happy with slice 3, and they're happy with slice 4. Is there a possibility? Let's see. It looks like, though, that Tanner, before we look at player 2, it looks like that Tanner only now likes the first slice. So we have to give that first slice to Tanner. So let's cross out that first slice for the other 2. And then, so player 2, they're still okay with this piece or this piece. But Win has to have, if player 1 and player 3 got those slices, we see that player 4 has to have this last slice to be happy. And so going back to player 2, they can't have that slice. And so they're going to get the slice 3, the remaining piece. So here's one option of a fair share. So we want to kind of keep doing that. And so player 1, the other option for player 1, if we had started this whole thing over, we could have given them the second slice instead, or I'm sorry, the third slice instead of the first. This is where I was thinking that maybe having that extra table here. Yeah. Okay, I'll just leave it there. So we were giving player 1 the third slice. And if we give player 1 the third slice, this goes away. They're gone. Player 2, they can either have, and let's see if there's anything that someone has to have now. And there's not. So let's say player 2 then gets the first slice. So that would take that away. And then player 3, the only thing that's left for player 3 that player 3 likes is slice 2. So that takes that away. And then the remaining slice for Win, player 4, this would equal the fourth slice. So I mean, we can go and do this again. So you can see where this could start getting tedious. So player 1. So I'm not sure if we found, no, if we found all of it. So looking at player 1 again, I mean, there's not really a choice. We can go to SF2 and SF3, but that could have changed things. Let's see. So player one, let's go back to getting SF2. So let me click this here and just stick it up here maybe. Okay, so if we give them SF2, so let's cross out SF2, Carlos is gone. Then we talked about how player Tanner had to have still the first slice. So player 2 equals slice 1. That second case then, when was that the only way we could do it? Yeah. So this was the only way we could do that with player 1 getting that second slice, the one that we had above. So that was a must. So let's go and change that, and let's look at him having slice 2 and see if we can change slice 3, not slice 2. So player 3 instead, we're going to give slice 3. Sorry, player 1 instead, let me slow down, we're going to give slice 3. Player 1, they got slice 1. So let's see, could they go and have just slice, because they want either slice 1 now or slice 4. So let's say they got slice 4. Let's see if that's possible. If that is the case, then Win has to have slice 1. Which would remain the S2 for slice 2 for player 3. So I don't think that there's any other option. Let's just try it. So player 1 again, slice 3. So slice 3. And player 1, slice 3. Player 2 had a choice of S of 1. S of 1. There, S of 4, S of 1, which was right. Player. Did we do it where player 2 got S of 4? That was S of 4. If they got S of 4, I'm sorry, I gotta look at this. S of 4, that's gone. We said Win would have to have. If they had got the first slice, then they, okay, that last one was the last one. Those are the only fair options I see. Now we could go and I don't know if we did this and just started with Sonia getting, I'm just curious if Sonia ever got piece 1, 3, or 4 in there. 1, 3, and 4, 1, 3. Yeah. Okay. I believe this is our fair share. possibilities. So we're going to look at one more example from this section. We had just stopped and paused, and I had you guys watch a video from the textbook that kind of explained a great overview of what we were doing with an example. And so I will link that for those of you who weren't in class to week 7 in the Canvas page by the end of this day. So looking at the next example, we have 4 partners, Adam, Benson, Cagle, and Duncan, jointly own a piece of land with a market value of $400,000. Suppose the land is subdivided into 4 parcels, S1, S2, S3, and S4. The partners are planning to split up, with each partner getting one of the 4 parcels. Okay, so we got land here and 4 parcels, and we got 4 players or 4 partners who are splitting up. Adams, Benson, Cagle, and Duncan. A, B, C, and D. And our land, we got S of 1, S of 2, S of 3, and S of 4. Okay, the total amount of land market value is $400,000. Okay, so that's the case, and there's 4 people. To me, then $100,000 for a market value of what they feel for that piece of land or more would be a fair share for a person. So 400,000, our fair share amount. Is that 400,000 divided by 4 players, which is 100,000. Okay, so we're getting into these players' preferences. And so it says to Adam, S of 1 is worth $40,000 more than S of 2. And S of 2 and S of 3 are equal in value. And S of 4 is worth 20,000 more than S of 1. Looks like we had some systems of equations here. Okay, we gotta go through this a little bit more. So let's get right through it. Let's now piece it together. So we're looking at Adam. And S of 1 is worth 40,000 more than S of 2. Okay, S of 1 is equal to $40,000 more. I know if I add $40,000 to S of 2, that's how much he believes S of 1 is worth. Okay, well, that's one equation. S of 2 and S of 3 are equal in value. And S of 4 is worth $20,000 more than S of 1. S of 4 is equal to 20,000 more. So 20,000 plus S of 1. Okay, and one other thing that we knew, right, was all 4 parcels, if we summed all 4 parcels, that was summed up to the market value of 400,000. So our goal right now is to figure out what S of 1, S of 2, S of 3, and S of 4 is just for Adam. Okay, let's there's a couple ways we can do this. We can, let's see, we can do some substitution in here and narrow this down. I know that S of 1, there we go. I know S of 1 right here is in this right here, right? So if I go in here and I do my substitution, then I know that S of 4, another way to write S of 4, this is equal to 20,000 plus S of 1. But another way to write S of 1 is 40,000 plus S of 2. Okay, so let's just simplify this. So I get S of 4 is equal to 20,000 plus 40,000. This is 60,000 plus S of 2. Okay, and I made a mistake. Up here when I was writing this down, I think I said it, I just didn't write it right. It said Adam believes that S of 2 and S of 3 are of equal value. So this should be S of 2 and equals S of 3. Okay, I think we got it. So we got, notice we have S of 1 is an equation in terms of S of 2. S of 3 is in terms of S of 2. And S of 4, S of 4 is in terms of S of 2. So we're going to use that fact. And so if we take S of 1, which is, we said $40,000 plus S of 2 plus S of 2, well, that's just S of 2, plus S of 3, well, S of 3, another way to say S of 3 is S of 2. Those are equal value, plus S of 4. And S of 4 we said was 60,000 plus S of 2. We know that that all has to sum up to this 400,000. So now we have one equation, one variable. And if we can figure out what S of 2 is, we can go back and plug it into each of our equations up here to figure out what the other one is. Okay, so let's simplify this one side down and then we'll isolate the variable on one side, get the constants on the other. And so let's look at S of 2 plus S of 2 plus S of 2 plus S of 2. If I sum all those up, there's 4 S of 2's. Plus, well, 40,000 plus 60,000, that's 100,000. This is equal to 400,000. So let's get S sub 2 by itself. Let's subtract 100,000 on both sides. It's an equation, so what you do to one side, you do to the other. And so we have 4 S sub 2 is equal to 300,000. So divide both sides by 4 to get S sub 2 by itself. So S sub 2 in this case is equal to 300,000 divided by 4. So that would be 75,000. Okay, so from there, we can figure out what S sub 1 is. Well, S sub 1 was equal to 40,000 plus S sub 2. So that's equal to 40,000 plus 75,000. Which gives us 115,000. Okay, so that's S sub 1 for him. This was S sub 2. So S sub 3 and S sub 2 are the same. So we know that if S sub 2 is 75,000, we know S sub 3 is also 75,000. And then S sub 4, well, S sub 4, that was the 60,000 plus S sub 2. So that's 60,000 plus 75,000. Which is 135,000. Okay, so from that information, we were able to at least make the table for Adam. I'm just going to go up here so I can see it. So Adam, S sub 1, we said was $115,000. S sub 2, we found to be the, that's the one we got, right? 75,000. S sub 3 is 75,000. And S sub 4, we said was 135,000. We said that the fair share was 100,000. So for Adam, he would believe only parcel 1 or parcel 4 would be a fair share for him. And so part A, determine which of the 4 parcels are fair share for Adam. And so that's how we did that. So the others are similar kind of way of filling this out. And so it's looking at giving you different equations. They're giving you information. You're going to have multiple equations, multiple unknowns. And so there's 2 ways to solve systems of equations. You can do substitution method, which we were doing to get it to one variable to figure out what that is, or you can do addition/elimination method. called either addition method or elimination method, depending on book or where you are, is another way to work with systems of equations. So let's stop there because we're pretty much out of time, and that's a good spot to stop.